Let us start with 3 Omkars together. Adopt Dhyana Mudra. Gently close your eyes. Breathe in. Ah. 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 Please join your palms. Yogena chittasya padena vacha malam sharirasya cha vaidyakena yopakarotam pravaram munina patanjalim pranjaliranatosmi आबाहु पुरुषाकारं शङ्खचक्रासिधारिणं सहस्रशिरसं श्वेतं प्रणमामि पतञ्जलिम्. हरि ओम. So, is it visible? Slides? I can't see all of you, so just unmute and tell me, Parul.
Yeah, yeah.
Yes, doctor.
Okay, thank you. Because in this Google Meet, I cannot see while sharing the screen. Endocrine system. What is endocrine system? Actually, endocrine system is related with hormones and is made up of network of glands. There are two types of glands in our body, exocrine and endocrine glands. So exocrine glands, they have duct. They are with duct and they secrete chemicals and they pour it or they just through the duct they are communicating with our body or in blood they are pouring this secretion or in target organ. But endocrine glands synthesize and release the classical hormones into the blood without duct. That's why they are called as endocrine glands. They are also called as ductless glands because they secrete hormones. Hormones are the chemical messengers. They are synthesized by endocrine glands and transported by blood to the target organs or tissues. That is called as site of action. Now, we had already seen about homeostasis, so maintaining internal environment, and so that our systems can work together and with coordination. For that, to achieve that homeostasis, major role play. There are two systems playing major role. First is nervous system and second system is endocrine system. That's why nervous and endocrine systems are called as major systems, balancing, regulating, governing our remaining systems in our body. Now, endocrine hormones or endocrine glands, they secrete these chemicals or they are called as hormones. And hormones are responsible for various mechanisms or various activities happening inside our body. They are essential material to carry, maybe for example, metabolism. Common example of hormones is growth hormone or insulin. So very common, insulin, we all know insulin is responsible for utilization of blood sugar. So not utilization, it is responsible for transportation of blood sugar into cell, and then cell utilizes this blood sugar and produces energy in the form of ATP. So that's how all the glands, they secrete chemicals, and those chemicals are very, very IMP for all systemic functions. Now, endocrine and exocrine, this point is clear. Endocrine means they are ductless glands, and exocrine glands are with duct. Examples of exocrine glands are mammary glands or sweat glands, lacrimal glands present in eyes, and salivary glands. We already saw in gastrointestinal system. And endocrine glands, example of endocrine glands. There are hypothalamus, pineal gland, pituitary gland, thyroid gland, parathyroid gland, thymus, adrenal, pancreas. Pancreas is exocrine as well as endocrine gland because pancreas has duct, and it has endocrine function also that we are going to discuss again. Then ovaries and testes. Now, major functions of endocrine system: growth and development, homeostasis, internal balance of body systems, metabolism, reproduction, and response to stimuli. For example, stress, anxiety. So, how to respond to that stimuli? So, all internal mechanism depends on how your endocrine system is working and how your nervous system is communicating, how well your nervous system is communicating with your endocrine system. So endocrine system completes this task through the network of glands, which are small but highly important organs that produce, store, and secrete hormones. And mechanism of action is secreting hormones. Then uh, through blood, they transport these hormones to the target organ or target gland, and there it starts functioning. So you need to memorize names of the I would like to suggest you, like, it's important, you should memorize all the names of endocrine glands at least. So hypothalamus, pineal gland, pituitary gland, thyroid, parathyroid, thymus, adrenal, pancreas, ovaries, and testes are major important endocrine glands in our body. Location, you can see here: pineal gland, hypothalamus, pituitary, and pineal gland are located in brain. Then thyroid gland and thymus gland, throat area, and thyroid in throat area, thymus in chest, pancreas near below stomach, adrenal glands above kidneys, ovaries in uterus, and testes in male genital organs. So, like that, locations, they are all over in the body, and depending on their location, their function varies. They have different functions. Their hormones they are secreting, they carry or they conduct different kinds of functions. We are going to see one by one. First is hypothalamus. Hypothalamus is present or located inside the brain. So here you can see this is brain, and hypothalamus is inside the brain. Hypothalamus is connected with pituitary gland. So this connection is there. This is hypothalamus, and there is small connection between hypothalamus and pituitary gland. Then pineal gland is located posteriorly to the pituitary gland. This is small brain, and above that you can see anteriorly pituitary gland and posteriorly pineal gland is located. So location is clear now. Hypothalamus inside the brain, just below the thalamus. This is middle part of the brain. Cerebrum is it is our big brain. It is called as big brain, and the cerebellum is called as small brain. And this is the middle part, and deep inside this middle brain or midbrain, this hypothalamus, and above that thalamus, all the important structures are there. And hypothalamus has endocrine function, as well as it is the major autonomic center of our body. It is performing lots of functions simultaneously. Like, it is related with autonomic nervous system. That means half of the brain's function, autonomic function, is under control of hypothalamus. And it is controlling endocrine functions also, because it is connected to pituitary gland and it is governing all the functions of pituitary gland. And pituitary gland is master gland, and on pituitary gland, rest of the glands, their function depends on function of pituitary gland. So this hypothalamus is major important structure of our nervous system as well as endocrine system, because it is the part of our brain also, and it is part of our endocrine system also. Hypothalamus secretes antidiuretic hormone, corticotropin releasing hormone. Antidiuretic hormone, short form ADH, corticotropin releasing hormone, CRH, gonadotropin releasing hormone, GRH, oxytocin, then prolactin controlling, prolactin and thyrotropin. So not necessary, it is not compulsory to memorize all the names, but just keep in mind that major control is here in hypothalamus. Hypothalamus is secreting these hormones, and because of that, pituitary is able to produce all the hormones which are very much necessary to carry all the functions of remaining glands. And secretion of pituitary, if pituitary is making hormones properly, then only it will be pituitary will be able to send towards the remaining glands, and then remaining glands will start functioning and producing and secreting their respective hormones. So this is chain. This mechanism is how all the glands of endocrine system are connected with each other. They work with each other in coordination, and this chain is called as axis. Like, hypothalamus is connected with pituitary. When hypothalamus secretes all these hormones, it sends these hormones towards the pituitary, and then pituitary starts secreting its respective hormones, and this connection is called as hypothalamo pituitary axis. Then pituitary sends specific hormones towards thyroid gland. So hypothalamo pituitary thyroid axis. Then pituitary sends some important hormones towards ovaries. Last time we saw luteinizing hormone, follicle stimulating hormone. So that axis is called as hypothalamo pituitary ovarian axis. So this chain is connected, it is interlinked, and it depends on how hypothalamus is functioning. If hypothalamus is not properly secreting these hormones, then rest of the glands, they become again their function starts decreasing, or some abnormalities starts happening inside our body. So it's that clear. Hypothalamus connected with pituitary, pituitary connected with rest of the endocrine glands in our body, and this connection is called as axis. So hypothalamo pituitary axis, hypothalamo pituitary thyroid axis, hypothalamo pituitary ovarian axis, hypothalamo pituitary adrenal axis. So like that it works. ADH hormone increases the amount of water absorbed into the blood by the kidneys. So last time we saw in excretory system this reabsorption of water and that procedure while formation of urine, that mechanism we saw. So increase the amount of water absorbed into the blood by the kidneys. So for that mechanism, this antidiuretic hormone is necessary. Otherwise, this absorption is not possible for our system or our excretory system. Now, in short, try to just, it is not possible for you, and I am not expecting from you to memorize all the functions, all the names initially, but still try to understand the mechanism. Don't stress yourself that how I am going to memorize this and how I am going to.
I think Parul and Divya, you make an acronym for this. Yeah, this.
It's very difficult because we cannot
There
expect
are,
from them.
what you should do if there are three P, P raised to whatever. So that way you can.
Like we are doing in school time, so that you can do. But yeah, once you understand mechanism, it is easy. So corticotropin releasing hormone helps regulate metabolism and immune response by working with the pituitary gland. So this axis is bigger. So this corticotropin releasing hormone requires for two major functions: to regulate metabolism and immune response. So it goes to pituitary first, then pituitary gland sends proper specific hormones towards adrenal gland to release certain steroids, because adrenal glands are responsible for production and secretion of steroids, that we are going to see in that section, adrenal gland. So like that, this connection in and communication is there, this communication with each and every gland, communication of hypothalamus with pituitary, communication of pituitary with other glands is very important. And this communication happens because of receptors or in blood. When for example, if thyroid gland is secreting two types of hormones, major two types, there are three, but T3, T4, and calcitonin. So if T3 starts, amount of T3 starts decreasing or lowering in our blood, so that difference our receptors can make it out immediately, and they sense this message towards hypothalamus. So hypothalamus finds out that T3 levels are going down. So I should make more thyroid stimulating hormone, releasing hormone. So then hypothalamus starts working on it. This is called as negative feedback. Last time we saw positive and negative feedback. Then hypothalamus sends this thyroid stimulating releasing hormone towards pituitary. Then pituitary starts secreting TSH more. Then it starts sending TSH towards the pituitary gland. So like that, this communication through receptors, through this negative and positive feedback mechanism, and this chain or axis is very important while understanding this endocrine system. So names and functions, that is another thing, but initially try to understand this and then try to memorize all the names, right? So corticotropin releasing hormone is related with steroid production by adrenal gland, but it is secreted by hypothalamus. Then gonadotropin, gonads means last time we saw ovaries and testes. Uh, those are called as gonads. They produce hormones related with um, estrogen, progesterone. Last time we also saw menstrual cycle. So major hormones like testosterone. So they are producing those types of hormones which are very much essential for reproduction. So in gonadotropin releasing hormone instructs the pituitary gland to release more hormones that helps in functioning of sexual organs. Then oxytocin is a hormone involved in several processes, including lactation, moderating body temperature, and regulating sleep cycles. Prolactin controlling hormones tell the pituitary gland to either start or stop the production of breast milk in lactating mothers. So, prolactin is not secreted by hypothalamus, but production is controlled by hypothalamus. Thyrotropin releasing hormone activates the thyroid, which releases hormones that regulate metabolism, energy levels, and developmental growth. So, is it clear? I hope it is clear. Initial mechanism is clear of endocrine system. Now we will see pineal gland, hypothalamus, has major functions of controlling pituitary and secretions of pituitary. Then pineal gland. Pineal gland, also called as conarium, epiphysis cerebri, pineal organ or pineal body. It is very important, and lots of research work is going on this gland. It is very interesting because we compare it with our third eye center. And in 17th century French philosopher Rene, he also compared this gland with third eye center, and lots of things are there on internet. You will find it out afterwards. So pineal gland, it secretes major hormone called as melatonin.
Rene Descartes has said that pineal gland is the seat of the mind.
Yeah, and it's very interesting, actually. So I tried to read that book, but I couldn't understand. His language is very higher level.
In fact, there is a book, the Story of Philosophy by Will Durant. That,
Okay.
yeah, that is a book must read. Actually, you have to master only 14 philosophers. Socrates, not much is there. Then the first philosopher is Plato.
Yeah, Plato.
Then after Plato, Aristotle. So Aristotle studied under Plato for 20 years. After that, one day he walked up to him and he said, "Sir, uh, Plato is dear to me, but truth is dearer. I'm leaving." And he did wonderful job. If you
Yeah,
look at the compartmentalization, no, that came after Aristotle.
yeah, but Rene's writing, it attracts me, but it's ये ऊपर से जाता है पूरा पढ़ने के बाद.
Yeah, because most of them were existential philosophers.
Yeah,
I exist because I, you know, I exist as a result I can see. So, whether I exist or thought exist, all those things.
yeah,
So, Story of Philosophy is a good book, small book.
yeah. I will
Yeah,
definitely read.
Will Durant.
Okay, chal. Next
Sorry.
about this pineal gland. Melatonin is important hormone. It controls, or it has that control over our circadian rhythm. So sleep cycle. Mainly, if we are sleeping on time, then only we are going to wake up on normal right time. Otherwise, this sleep cycle always gets disturbed, and our sleep cycle is very much connected with our circadian rhythm. So regulation of circadian rhythm, the 24-hour cycle of biological activities associated with natural periods of light and darkness. So this melatonin starts secreting after sunset, so it needs dark. And nowadays what happens, we keep on working in front of laptops, and we sit in front of TV, and then this light, it misguides our pineal gland, and it then this melatonin secretion lowers down. So that's why this sleep disturbances and other whatever symptoms we are facing with now, with our day-to-day routine, by we are not able to connect our routine with nature or natural cycle. It's because of that. So this melatonin is very important gland, and it melatonin is produced according to the amount of light a person is exposed to. Means what? So morning sunlight, if you are sun gazing in our yoga shastra, we know trata kriya is there, surya tratak is there. So in morning sunlight, if we are gazing at sun for 2 to 3 minutes, that is sufficient. It activates our pineal gland, and it sets that clock, so that our pineal gland, after 7 to 8 hours, it understands then. If we are sun gazing every day, then our pineal gland, it understands that after certain hours, maybe at 9 o'clock or 7 o'clock or 8 o'clock, when sun sets, I need to start secreting this melatonin. So that's how this cycle gets regulated. But nowadays, we are not doing that sun gazing. We are not waking up on time. And when sun comes after 12 o'clock or 1 p.m., people wake up and then they start their regular routine. So that is very disturbing for production and secretion of melatonin. So this hormone is responsible for regulation of circadian rhythm and sleep cycle. For natural sleep, actually, it's very much essential. So what happens? One more research is going on this gland related with growth and thyroid function. So pineal gland can alter the behavior of pituitary gland. It has that effect also because it is also located in brain, and melatonin may block the pituitary gland from secreting hormone that play essential role in the development of the ovaries and testes. This is interesting because now lots of ailments related with ovarian function, testes, or testosterone levels people are experiencing. So that is because of their disturbed sleep cycle, and that's why this pineal gland is disturbing this ovarian and testes functions also, and even influencing menstrual cycle also. As people age, the pineal gland tends to secrete less melatonin. That is natural. And it is unlikely that melatonin is the sole culprit for age-related changes, but reduced level of melatonin may help uh, explain the aging process. So older adults tend to sleep less and may have trouble falling asleep. Nowadays, people are taking supplements. Melatonin supplements are available outside, but they are synthetic. So it's better to go for natural remedies instead of going for that synthetic productions. You can just follow this Surya Tratak also. That is also sufficient to adjust this cycle and production of melatonin. Even Jyoti Tratak is also good. Next gland is pituitary gland. Pituitary gland is located in brain, just near to the hypothalamus. Here we saw this is pituitary gland. It is very small in size, green pea shape, and weight is about zero point 0.5 gram to 1 gram. So it's very small and very light in weight, but it has very great work to do in our body. Without pituitary gland, it is called as master gland. It is controlling all the endocrine system functions and endocrine glands which are present. So the pituitary gland is divided into two sections: anterior pituitary and posterior pituitary. This is posterior and this is anterior, and this is stalk where it is attached to the brain and part of the brain, and this is hypothalamus. Now this is hormone secreted by anterior pituitary, growth hormone or somatotropic hormone. So growth hormone is easy to memorize. It is responsible for the general growth of the body. Thyroid stimulating hormone or thyrotropic hormone is necessary for the growth and secretory activity of the thyroid gland. It has many actions on the thyroid gland. Adrenocorticotropic hormone, ACTH, is necessary for the structural integrity and secretory activity of the adrenal cortex. So adrenocorticotropic hormones, pituitary secretes it, then it sends it to the adrenal gland, then adrenal gland starts secreting specific hormones. Without this connection, adrenal gland will not be able to secrete steroids and other hormones, or they are also called as neurotransmitters. Then follicle stimulating hormones, FSH, stimulates the growth of ovarian follicles in the ovary before the release of the egg or ovum from one follicle during ovulation. So follicle stimulating hormone, luteinizing hormone are essential hormones for ovulation and maturation of ovum. Hormones of the posterior pituitary are antidiuretic hormone. It is also called as ADH, and oxytocin. So antidiuretic hormone is responsible for retention of water. It stimulates the kidneys to retain water in condition of water loss. And vasopressor action is causes constriction of blood vessels to increase blood pressure in case of severe dehydration. So it is related with kidney functions, reabsorption. It stimulates the kidneys to retain water. Whenever there is water loss, blood vessels, they start a contraction and constriction of blood vessels is because of this vasopressor action of ADH or antidiuretic hormone. Then oxytocin helps in the contraction of the uterine muscles during uh, the labor procedure, baby birth, thus aiding the process of childbirth. It also contracts muscles in the breast post childbirth, helping the release of milk. So posterior pituitary, two hormones, ADH and oxytocin. Anterior pituitary, growth hormone, thyroid stimulating hormone, adrenocorticotropic hormone, follicle stimulating hormone, luteinizing hormone. This is luteinizing hormone. This is present in males as well as in females also. So, luteinizing hormone is responsible for this testosterone production, and prolactin is necessary for the production of secretion of milk in lactating mothers. Next gland is thyroid gland. Thyroid gland is, it looks like this, butterfly shape. This bridge is called as isthmus, and two lobes of thyroid gland. This is called as thyroid cartilage. This is trachea or windpipe, and this is larynx or uh, vocal cords and larynx. Thyroid gland just below the Adam's apple. It is called as Adam's apple. It is roughly butterfly shaped with two lobes wrapping around the trachea and connected in the middle by isthmus. The thyroid gland is not usually palpable. Then thyroid hormone synthesis is governed by the hypothalamus. Again, this axis is always there. When circulating levels of thyroid hormone is low, the hypothalamus releases thyrotropin releasing hormone, negative feedback, and then this hormone travels to the anterior pituitary gland where it promotes the release of thyroid stimulating hormone, that is TSH. TSH enters the bloodstream and travels to the thyroid gland. This is the mechanism, how it works. Three major hormones are secreted by thyroid gland: thyroxine, triiodothyronine, and calcitonin. We are very much familiar with these hormones. Nowadays, hypothyroidism is very much common. So regularly doctors prescribe this blood test for thyroid function, TSH, T3, T4, TSH, isn't it? So TSH is thyroid stimulating hormone. So when thyroid stimulating hormone starts increasing in our blood, that shows thyroid functioning somewhere, it is affecting. And then T4, T3 initially they lower down and then they start increasing. So that's how this positive and negative mechanism is working. So T4 is also called as thyroxine and is in the inactive form, and most of it is converted to an active form called T3 by organs such as liver and kidneys. So T4 mostly is in inactive form, but liver and kidneys, they convert it into T3. Then T3 is the active form of the thyroid hormone or thyroxine. Approximately 20% of T3 is secreted into bloodstream directly by the thyroid gland. The remaining 80% is produced from the conversion of thyroxine by organs such as liver and kidneys. And calcitonin is involved in helping regulate levels of calcium. This calcitonin hormone is related with levels of calcium and phosphate in blood. So what it does, it reduces calcium levels in the blood. It absorbs calcium. It makes our bones to absorb calcium from bloodstream. However, the importance of this process in humans is unclear, um, as patients who have very low or very high levels of calcitonin show no adverse effects. Calcitonin reduces the blood calcium level by acting on bones, kidneys, and intestines. So, calcitonin is related with lowering blood calcium levels. This mechanism is not necessary, it's just for your information, but it is related, calcitonin is related with calcium absorption by bones, that you just keep in mind. Then parathyroid gland, these four yellow p-shaped dots you can see here, this is called as parathyroid gland. Four parathyroid glands. There are total four parathyroid glands which are situated on the posterior surface of the upper and lower poles of thyroid gland. And hormone is called as parathormone or hormone secreted by the parathyroid gland, which is essential for the maintenance of blood calcium levels. It works opposite to the calcitonin. So calcitonin makes bones to absorb calcium from blood, and parathormone is responsible for release of calcium from bone to the bloodstream. So on bones, parathyroid hormone stimulates the release of calcium from large calcium stores in the bones into bloodstream. So opposite action to calcitonin. This increases bone destruction and decreases the formation of new bones. On kidneys, parathyroid hormone reduces loss of calcium in urine. Parathyroid hormone also stimulates the production of active vitamin D in the kidneys. And on intestine, parathyroid hormone indirectly increases calcium absorption from food in the intestine. So, in absorption of calcium depends on parathormone or parathyroid hormone also through its effects on vitamin D metabolism. Thymus gland. Thymus is located in chest area. Here you can see this is thyroid gland, and below thyroid gland, between just below thyroid gland, between two lungs, this thymus gland is present. Thymus gland located behind sternum and between the lungs is only active until puberty. After puberty, the thymus starts to slowly shrink and become replaced by fat. Thymosin is the hormone of the thymus, and it stimulates the development of disease fighting T cells. So have you heard about this? These are very common nowadays. It's also uh, mostly people know about this T cells, the for immunity. The thymus gland will not function throughout a full time lifetime, but it has a big responsibility when it's active, helping the body protect itself against autoimmunity, which occurs when the immune system turns against itself. So autoimmune diseases are there. If you are aware about rheumatoid arthritis, so this is autoimmune disease. Our immune system starts attacking our bones only, our bones and cartilages. So for that, this T cells and thymus gland, it helps, thymosin helps, but after puberty, it starts shrinking. Before birth and throughout childhood, the thymus is instrumental in the production and maturation of T lymphocytes or T cells. It is related with our defense mechanism. T cells, T lymphocytes, we saw when we saw blood and cells, composition of blood at that time. So thymus is special in that, unlike most organs, it is at its largest in children. Once you reach the puberty, the thymus starts to slowly shrink and become replaced by fat. By age of 75, the thymus is little more than fatty tissue. Pancreas. Pancreas is endocrine as well as exocrine in function. It secretes digestive enzymes that is called as pancreatic juice, which helps in digestion, and it secretes hormones which control blood sugar level, insulin and glucagon. So endocrine function, islets or islets of Langerhans cells secrete hormones into blood vessels. And exocrine, that pancreatic juice is pancreatic through pancreatic duct. It is getting going towards the first part of small intestine that we saw in digestion procedure. Pancreas is about 6 inches, approximately 15 centimeter long, and is divided into head, body, and tail. Head, body, and tail. And here at the low, this is tail of pancreas, and here you can see the cells which produce insulin and glucagon. Insulin is released by the beta cells in islets of Langerhans, groups of pancreatic cells. Name of cells is that. So it is very common. I think you also know about that beta cells and pancreas. That is very common nowadays because of diabetes mellitus. In response to food, so its role is to lower glucose levels in the bloodstream and promote the storage of glucose in fat, muscles, liver, and other body tissues. That is the major function of insulin. Alpha cells in islets of Langerhans produce another important hormone called glucagon. This has the opposite effect of insulin by helping release energy into bloodstream from where it is stored, thus raising blood sugar levels. तो ये mechanism कैसे चलता है? जैसे blood sugar high होता है, insulin आ जाता है और it starts transporting insulin, blood sugar into cells. And when insulin levels कम होना शुरू हो जाते हैं, blood sugar drop होना शुरू हो जाता है, तो उस वक्त glucagon activate हो जाता है and it starts glucose balancing glucose levels in bloodstream, because glucose जो store रहता है हमारे liver में और बाकी के organs में, muscles में, so glucose mostly liver में से glucagon जो है वो क्या करता है, ब्लड स्ट्रीम में लाने के लिए उसको स्टिमुलेशन शुरू कर देता है. सो दिस mechanism ऑफ इंसुलिन एंड ग्लूकागॉन, it works, they work opposite to each other.
Doctor,
Yeah,
this islets of Langerhans are how much? I think around 1 million, no?
yeah, around, yes.
Because most of the diabetic practices are all based on that.
Yeah, it's based on that. And types of diabetes mellitus, one type is juvenile, where these cells are inactive. They are not able to produce insulin at all. So,
Type 1, no?
Type 1.
Due to injury also it happens, no?
Yeah, but mostly this is juvenile, matlab,
Yeah. In fact,
only
yeah,
hota hai.
in fact, my the person whom I used to report, his son, after an injury, then from there is no cure, he is on insulin.
Yeah, they are always depend on lifetime. They need this synthetic insulin from outside source only.
Thank you.
Yeah. So adrenal glands on the head of the or top of the kidneys. These adrenal glands are located. Outer part is called as cortex, and middle inside part is called as medulla. So cortex is secreting different hormones and medulla is secreting different hormones. Adrenal glands are also called as suprarenal glands. Supra means above kidneys or head of the top of the kidneys. Either of two small triangular endocrine glands, one of which is located above each kidney. So this gland weighs 5 grams and measures 30 mm, 1.2 inches wide, 2 inches, and 10 mm thick. So inner medulla produces or secretes epinephrine and norepinephrine. It is also called as adrenaline and noradrenaline. So these are very important hormones or neurotransmitters. And outer cortex, which produces steroid hormones, major hormones, which they are playing in lots of important functions in our body. Maybe you have heard about this steroids. People are taking, doctors prescribe steroids. Synthetic steroids are not good for our health, this and that. So this is our natural steroid making gland, and if it is not functioning properly, then we become dependent from outside source. So the two parts differ in embryological origin, and adrenal glands vary in size, shape, and nerve supply in another animal species. Then adrenal medulla is integral part of sympathetic nervous system. So medulla, which is inner middle part, and it produces epinephrine and norepinephrine. It is integral part of sympathetic nervous system. That's why this adrenaline and noradrenaline are called as neurotransmitters. They are communicating system with they are communicating system. So they neurotransmitters, they carry impulses towards the brain and nervous system, and they function, they they are sympathetic in function. So sympathetic nervous system is responsible for fight and flight response. So whenever there are adrenaline or noradrenaline levels are increasing in our blood, sympathetic nervous system is hyper functioning, and that is not good. Always, if it is hyper functioning, that is not good for our all the systems and health. The sympathetic nervous system and the adrenal medulla are collectively known as sympathoadrenal system. Then dopamine also part of this system. Some amount of dopamine gets secreted by this adrenal medulla, some in basal ganglia. Dopamine is reward hormone or reward, we can say, goal setting, goal achieving goal. For that we need this dopamine. Then norepinephrine and epinephrine, when stimulated by sympathetic nerve impulse, the hormone enters into circulation, all these hormones, and process is known as exocytosis. No need to memorize this again, just names of the hormones. That is important. Then
Doctor,
yeah,
uh, even like when you said hyperfunction, that is the time when cortisols are released.
yeah, that's why the in stress, mostly in stress,
Yeah.
it
Oh,
happens.
what a what a what a wonderful function. The same organ, take care, you get all the happy hormones.
Yes, yeah, it's very interesting actually. This
I was just going to say that dopamine is known as the happy hormone, and the
Yeah,
same thing releases stress hormone also. I was
yeah.
yes,
just going to say that.
All that dopamine, oxytocin, endorphin, serotonin, all
some
of it.
part means not all the dopamine, but
Yeah, little bit.
amount of, and more in brain, in basal ganglia. So dopamine is hormone of reward, and it is required to achieve goals, to complete some. And if it is not there, then Parkinson's disease is related with dopamine deficiency.
Okay.
Yeah. So when our cells and our adrenal glands, they are not able to secrete a required amount of dopamine, then this Parkinson's develops gradually.
Okay, okay. That is why this deep brain stimulation is done.
Yeah.
Yeah, now I'm able to relate. That's one of the major cure for.
Yeah. But it's very difficult when it starts developing. Then reverse is very difficult for in Parkinson's,
Correct.
because the symptoms, they are very much difficult to handle physically, mentally, and dopamine secretion is required, and that's why this brain stimulation, or all these methods are there. And the steroid part, steroids are also important. So mineralocorticoids, glucocorticoids are important steroids. We need these steroids to carry functions like this mineralocorticoids, minerals. So sodium, potassium, the most important of which is aldosterone, chemical name. The hormone helps maintaining the body's salt and water levels. So sodium levels in body, in blood, and which in turn regulates blood pressure. Without aldosterone, the kidney loses excessive amount of salt and consequently water, leading to severe dehydration and low blood pressure. So then vasopressin we saw by posterior pituitary. So that's how this homeostasis is getting balanced. So when this is not there, vasopressin starts working. Then it stops that loss of water or sodium. So this aldosterone also functioning here. Then glucocorticoids hormone in this group is predominantly called as cortisol. Cortisol hormone is involved in the body's response to illness and helps regulate its metabolism. Illness and metabolism. Cortisol stimulates glucose production, helping the body to free up necessary ingredients from storage, fat and muscles to make glucose. Then cortisol also has significant anti-inflammatory effects. So in inflammation, sometimes doctors gives us glucocorticoids, synthetic preparations of cortisols. In asthma, also they use this for as an anti-inflammatory. But these synthetic steroids, they have masking effect. They work immediately. They show results, but their results are very temporary. After some time, 8 to 10 hours, again body goes into same situation. So that's why these steroids, it's better to make our body that much capable, so that we will not need this synthetic steroids. uh, for the dependency happens after some days. We become dependent on the steroids. Then
Ma'am,
at
previous one is this glucocorticoids.
yeah, cortisol is the main anti-inflammatory effect.
I'm trying
Doctor,
to
I have a
take.
question.
Yeah,
Yeah,
Yes, sir.
I'm trying.
Is it the same hormone that these dermatologists prescribe these days? A lot of people are going into that skin whitening and all that. Is it the same stuff what they are doing?
little bit chemical structure difference is there,
They
but
doctor can tell they use more for this bottom.
yeah, because
Divya will have somebody nearby, Dr. Jyotsna.
Yeah, she's in my society only.
Yeah,
Yeah.
so they do all that thing.
they use steroids because it gives results immediately. The steroids gives results in fungal infections, skin infections, then dermatitis, lots of skin conditions. They give results, but it's very temporary.
Actually, I am trying to help a small, one of my friend's sister's daughter. 5 years she was on for workout.
Oh,
Yeah. So now slowly I said next 6 months, no, we will you use once. Okay. But along with that, I have put her to Anulom Vilom, Brahmari, all those things. So I said, only taper it down, don't stop. Because she is in a far off place.
tapering, yeah, gradually we can decrease doses, but suddenly stopping means body is now dependent because she's taking since 4 years. So we need to tapering doses also only. But yeah, there are lots of magical effects of synthetic steroids in asthma, in dermatitis, in psoriasis, in rheumatoid arthritis. For immediate pain relief, they need steroids. Otherwise, it becomes very difficult for that orthopedic doctor also to control their pain and that swelling and everything. So for inflammation, as an anti-inflammatory action, these synthetic steroids, they help, but dependency is very much difficult to handle them afterwards, after some years. Then our body develops resistance and dosage starts increasing.
Ma'am, many skin infections are also part of autoimmune conditions only, na? Like psoriasis.
Yeah, psoriasis, then dermatitis sometimes. Uh,
Okay.
yeah. I- it's okay if we will continue for 10 minutes because two systems are remaining. We will
Yeah,
That's
complete.
fine.
no problem. As long as our two small girls are fine.
Parul, okay?
I I went to the doctor's place and all those attendants are very close to me. So I told them that I wanted to quickly move out, and they said no problem because whenever I come from my hometown, no, I
Hmm.
give them you know traditional chips and all those things. So
Okay.
yeah, you should always service your relationship, not when you want. Sorry, carry on.
Okay.
Now next 10 minutes I will not talk.
So these are steroids, little information about steroids. Then adrenal androgens, these are the male sex hormones, mainly testosterone and DHEA. Nowadays it is very much in fashion. Dehydro, whatever it, even I cannot pronounce properly. So they have weak effects on bodily function, but play a role in early development of the male sex organs in childhood and female body hair during puberty. So adrenocorticotropic hormone ACTH secreted by the anterior pituitary gland primarily affects the release of glucocorticoids and adrenal androgens by the adrenal gland, and to a much lesser extent also stimulates aldosterone release. So these androgens are sex hormones, and they are responsible for this testosterone secretion and by testes and development of male sex organs. Then next is ovaries. Ovaries, female sex hormones, they produce female sex hormones, mainly estrogen and progesterone. Both the hormones are responsible for femininity, for development of secondary sexual characteristics, making for baby birth. Both the hormones are very much required. Menstruation, baby birth, fertility, and at the time of menopause also, their influence is there on all over the female systemic functions. So ovaries, they produce estrogen and progesterone. But how this mechanism happens? Again, this axis is there. So the ovaries secrete both estrogen and progesterone into bloodstream, and thus they are important endocrine glands. Primary function of the ovaries is to nurture and prepare oocyte or ovum in premature state for the process of ovulation. Once the ovum is released, it migrates towards the fallopian tubes to the uterus. While in the fallopian tube, an ovum may be penetrated and fertilized by a sperm. If an egg becomes fertilized, it will implant into wall of the uterus, and the process of ovulation and fertilization are controlled largely by the cells in the ovaries that produce the and secrete hormones. Which are those hormones? Estrogen and progesterone. So how this puberty thing happens? In short, what happens? Puberty begins with secretion of gonadotropin releasing hormone from the hypothalamus. So first important hormone is gonadotropic releasing hormone, which is secreted by hypothalamus at certain specific age, maybe at the age of 10 or 11. Around that, puberty begins, and then this hormone starts secreting. Secretion starts of GnRH, Then what happens? This GnRH is responsible for, it goes towards, or it get hypothalamus sends it towards the pituitary gland, and then pituitary secretes follicle stimulating hormone and luteinizing hormone in significant quantities or moderate quantities. Then what happens? Then increasing secretion of gonadotropin leads to increasing production of estrogen by the ovaries, because pituitary gland starts sending luteinizing hormone and towards the ovaries. Estrogen stimulates the development of secondary sex characteristics in the and the maturation of ovarian follicle. And increased secretion of estrogen normally occurs between ages of 8 and 14 in girls, and then menarche start, that menstruation starts, and that cycle we had already discussed in last session. That's how it works. Hypothalamus secreting gonadotropic releasing hormone GnRH, it sends it to the pituitary gland. Pituitary then starts secreting luteinizing hormone and follicle stimulating hormone. Then it sends these hormones to the target gland, that is ovary. Then in ovary, estrogen and progesterone secretion starts happening, and then menstrual cycle, menstrual bleeding. And if pregnancy or conception happens, then estrogen levels starts going down and progesterone level starts increasing, because progesterone is responsible for continuation of pregnancy. And if fertilization is not there, then progesterone levels also drop down and menstrual bleeding starts, right? So here again, I had mentioned all the influence of estrogen and progesterone on menstrual cycle and ovulation. Testes, as I had mentioned, testes are oval-shaped male reproductive glands that produce sperm and testosterone. So the production of testosterone by the testes is stimulated by, again, luteinizing hormone, which is produced by the anterior pituitary gland and acts via receptors on the surface of the living cells, part of testes. Specific or specialized cells called as Leyding's or Leydig cells. The secretion of LH is stimulated by gonadotropic hormone, gonadotropin releasing hormone, which is released from hypothalamus and is inhibited by testosterone, that is negative positive feedback, and which also inhibits the secretion of gonadotropic releasing hormone. So that's how it's similar to ovary, and just now we saw like how estrogen and progesterone secretion starts because of luteinizing hormone, and who is responsible for that? Hypothalamus. Hypothalamus is sending gonadotropin releasing hormone. Same thing happens in males, but the secretion of testosterone starts in testes and production of sperms. The whole mechanism is in this diagram. You can see hypothalamus, hypothalamo-pituitary axis. Then pituitary is sending hormones towards the target glands, growth hormone, breast, prolactin, ovaries, testes, luteinizing hormone and follicle stimulating hormone. Ovaries are producing estrogen and progesterone. Testes are producing testosterone. Pituitary is sending adrenocorticotropin hormones towards the adrenal cortex. Cortical hormones and we saw neurotransmitters like adrenaline, noradrenaline is getting released. Then thyroid stimulating hormone towards thyroid gland, thyroid hormones, T3, T4, calcitonin. Then posterior pituitary, vasopressin towards kidneys, oxytocin, breast and uterus. Like that it functions. Any questions? Just let me stop the recording.